Woo! What's up, guys? Welcome back. Sorry, I just ran to grab my earphones. I had everything in my setup except for the earphones. So, but welcome back. Dr. Jaws here, and tonight we are diving back into the Twilight Zone to meet the Taillight Shark, Euprotomicroides zantedeschia. So I'm pretty excited to learn more about this species. Hey, Howard, welcome back. Hope you had a good weekend. Let me know if you did anything fun this weekend. I pretty much took it easy for the most part. The year is starting to wind down a little bit, so it's still really green here in Virginia. So it's not quite feeling like fall yet. We've been getting a lot of rain with the. It's actually really sad. We have we're not getting the hurricane, but like a lot of the southeastern states are really getting hit by it. So we're getting like the tail end of it, or not the tail end, but like I guess the outer rim of it. So it's been raining pretty much all week, actually, but nothing really horrible, fortunately. But hope you had a good weekend, and hope you've been doing some fun things over the weekend. Again, I've just been taking it easy, just been doing a lot of writing, and let me know if the music is too loud, by the way. But I'm excited to talk about this shark species, just because it's like I'm not very familiar with the taillight shark. I don't think I've actually heard of the taillight shark until we picked it last week. I know it's a kind of lantern shark, but it's in a different genus. So Emopterus is like the classic lantern shark genus, but Euprotomicroides is something a little bit different. So I'm excited to learn more about it and see what kind of makes this group of sharks unique. So, but unfortunately, we don't have footage for the species. It's kind of a rare species, or a rarely seen species. So we're going to be focusing kind of more on the research tonight. And yeah, so we'll go ahead and dive in. And I'm wondering where to start. There is quite a lot of research. So I think we'll start with maybe fish base is a good place to start for the taillight shark, and then we'll check out shark references, and then we'll take a look at bioluminescence. I do have a kind of a cool clip though. This is not this species, but it is a cool example of bioluminescence. So most people who think of bioluminescence, they think of like deep water sharks, or fireflies are an example of bioluminescence. But there's also shallow water environments that have it. So this is a cool example of a different shark species swimming through bioluminescent plankton. So you can see as the shark swims through the water column, it's actually bumping into all of the plankton, causing the plankton to kind of give off their light, and the plankton's glowing blue. So it's a really cool phenomenon to see. Different parts of the world do have this. I've mentioned this before on the channel, but we actually do have this in the United States with comb jellies. So comb jellies, if you bump into them, they also glow blue. This is a little bit finer because this is actually plankton. So for comb jellies, you see like these like little blue blobs that glow when you bump into them in the United States. But in other parts of the world, Puerto Rico is probably the most famous location with the Bio Bay. There's actual plankton that glows blue when it is being disturbed, either when the waves are crashing on the shore, or if people are kayaking in the water and the paddles hitting the water and the boat's going through the water, or like the shark. The shark is swimming through the water and kind of giving off the blue light because it's hitting or running into all this plankton that is having this kind of chemical reaction. So it's a really cool phenomenon, and it's a really beautiful thing about the ocean that I love, that is actually a lot more common than people would suspect, or people would think, bioluminescence being in shallow water. So it's a really, really cool thing. There's some beaches that you can walk on the sand and it will glow because of the bioluminescent plankton that are still alive as you step foot there. So, yeah. As far as North America, Puerto Rico is the only place I've ever heard of with bioluminescent plankton. But on the East Coast of the United States, bioluminescent organisms are pretty much all up and down the coast as far as like comb jellies go. So, pretty cool phenomenon. And then I do have a clip of lantern sharks. And it's kind of more like a zoom in on a study. But again, kind of illustrating how lantern sharks have the photophores on their bodies. So, and these photophores also give off bioluminescent. The distribution of the photophores is different between species. So some species will have kind of like the striations. Some species will have, like, my favorite one is probably like the cookie cutter shark, where it has like a collar, like a blank space. And they might show that here. And then some species have like a huge concentration of bioluminescence on the bellies of the shark, and then less of a concentration on the back, which is kind of like counter shading. So kind of fits into. That's a cool aquarium shot of a scout hammerhead. It looks like a scout hammerhead, but it's kind of like a cool feature of like counter shading where light is coming from the surface, the depths are dark, and so if you see a shark from above, you see a dark back. If you see a shark from below, you see a light belly, and it's pretty cool to see. But what I'm most curious about is where the bioluminescent distribution is on the taillight shark. I'm assuming it's on the tail, hence the species name. So we'll check that out. So we don't have a lot of photographs or footage of the species, but we do have a couple illustrations of Euprotomicroides zantedeschia, or taillight shark. So here we go. So FAO description of the species. It's actually a pretty nice illustration here. So things you can immediately see, you have like a blunt snub-nosed snout, and this actually looks a lot like a pocket shark almost. Pretty cylindrical torpedo-shaped body, or I guess you could say like a bullet-shaped body. The pelvic fins are really interesting because they're very close to the second dorsal fin, and they're actually about the same size as the second dorsal fin. And these three make an interesting triangular shape altogether. Like they're positioned actually really closely together, and they're actually comparatively really large. You do have a nice light margin on the back of the caudal fin, and light margins on the back of the pectoral fin and pelvic fin and the dorsal fins too. So I'm curious if these are bioluminescent features. What's kind of fascinating here is that the first gill slit is very small, second gill slit slightly larger, third gill slit larger still. It's a very strange arrangement. Usually sharks have equal sized gill slits. And also the spiracle is pretty large on this species as well. So lots of unique, weird little features. So not just as far as like the coloration, because we'll learn more about how this species glows in the dark in the deep sea environment. But also in terms of its just physical features, its physiology. The body compared to the fins is actually pretty elongate, so it's kind of like, it kind of reminds me of like a sperm whale. I mean, it's a very small shark, but it does kind of remind me a little bit of a sperm whale with like the paddle-shaped fins and the very long, like cylindrical-looking body with like the squarish kind of blunt snout. And actually, comparatively, it's a pretty large jaw too, compared to the size of the species, or the size of the animal. The pectoral fins pectoral fins are also proportionally really large. The first dorsal fin is actually quite small. So interesting shape, and I'm curious as we learn more about this shark's biology, if there's any particular reason for some of its features. Let's see. Euprotomicroides, Greek suffix meaning like, resembling, having the forum, referring to the resemblance of Euprotomicroides. Zantedeschia, referring to Zantedeschia ethiopica, South African arum lily, after which arum Cape Town traveler, for which the holotype was collected, was named. Interesting. It's a benthopelagic species ranging around 205 meters. I've read in Sharks of the World that it's actually 600 meters deep, so that's definitely Twilight Zone. and distribution, it lives off of Cape Town, South Africa, off Uruguay and Argentina. So it's a Southwest Atlantic species. Kind of fun fact: the Southern Ocean, which is the ocean between, or the ocean in the South Atlantic between South America and Antarctica, or South Africa and Antarctica, or Australia and Antarctica. It's infamously the roughest seas in the world because it's a continuous body of water that circulates without colliding into a continent. So let me see if I can get a picture of that. Yeah, that's actually a really great illustration of that. Yep. Okay. So this is what I'm talking about. So we're talking about how the taillight shark lives in South Africa and then southern South America. And this is talking about gyres. So you do see ocean currents creating these gyres around the world. So up here you have like the North Atlantic gyre. So this is like the Gulf Stream, the North Atlantic drift coming back down into like the Canary Current. So this is the circle that makes. South Atlantic gyre, Indian Ocean gyre, South Pacific gyre. The Southern Ocean is infamously the worst ocean, like the worst as in the roughest conditions in the world, because this gyre surrounds a continent, is not blocked by a continent, and so like it's this constant movement of water in a circle, and so it's infamously like extremely dangerous for ships to cross. Like you have to be very careful and time it very right as far as you know, going, if you're traveling to Antarctica, if you're a ship traveling to Antarctica, you have to be especially careful in terms of like what the weather looks like, because this gyre is such a powerful force. And it's kind of cool to see because the other gyres, they kind of come in on themselves and they are not really like, they're not going around the world, like spinning around like the axis of the world. They're kind of, the continents are pushing them into each other. But the Southern Ocean gyre is, because of where it's located, it's unstoppable as far as like it does not have interference really from a continent. So it creates really, really rough conditions. So kind of cool fact that thought would be kind of a fun thing to point out with that. So, but getting back to our shark. Let's see, so this is a little guy, 42 centimeters. Let's convert that to inches. It's probably about a foot, maybe not even. Oh, actually, it's a little bit longer than a foot. So it's about 17 inches maximum length. So it's not, that's actually a fairly sizable shark. For like a lantern shark, for like the little lantern sharks, it's actually not that tiny, but... A small, compressed dogfish shark with a blunt snout, ear-shaped pectoral fins, and gill slits increasing greatly in width from front to back. Okay, so that illustration was very deliberate. That is a unique feature. We've never seen that from a shark before. So gill slits increasing greatly in width from front to back. I wonder why that is. That's so strange. Cloaca area with large luminous gland, not found in other sharks. Oh, okay. So this is already out of the gate, this is a pretty unique species. Brown with black underparts, fin margins conspicuously white. Biology, probably oceanic, but also near the upper slope. The haul type was caught in the bottom trawl between 457 and 640 meters. A second specimen was collected in the open ocean near the surface at less than 25 meters. Okay, so this is probably a species that does like the deal migrations. Like, so this is probably a small deep water shark that swims up to the surface at night, chasing prey items. So pretty cool species, or pretty cool behavior. A pretty cool group of sharks as far as the sharks that make those migrations. It's actually one of the largest, if not the largest, migration of animals on Earth. Are deep water animals moving upward to the surface at night for feeding. So. Food unknown, but the powerful jaws and sharp teeth suggest that this species can take relatively large prey. Okay. Probably ovoviviparous with few young. So this is probably a shark that it's giving birth to live. It's eggs inside the female individual that hatch inside the mother, and then the shark gives birth after that. So there's no like placental connection there. Okay, not much else in the species, so we'll take a look at shark references for more information. Discovered in 1966. A new genus and species of pygmy Taillight shark. So Taillightidae are the kitefin shark, so it's a kind of kitefin shark. In this illustration, you're seeing the same thing, where with the greatly increasing gill slits. Also, you're seeing the classic teeth of a kitefin shark, where you have these huge. I am assuming these are the lower teeth, actually. And these are the upper teeth, because I know kitefin sharks look really strange as far as, like, it almost looks inverted, where the lower teeth have, like, the big broad blades, and the upper teeth are narrow. I wonder if we can. I don't think it's going to show us that. So, what's also kind of eerie is, because this looks like kitefin shark teeth, I wonder if these are teeth that could be shed and swallowed, like the kitefin shark does, which is really. It still creeps me out that kitefin sharks do that, but we'll see as we learn more about this species. Here is a really, really terribly preserved specimen. So very damaged. It's hard to kind of tell details of it. The caudal fin looks pretty good. You can see the eyes are fairly large, and so is the mouth. But this is a really dried out specimen through preservation, so that actually won't really be super helpful. Let's see. Oh, a couple more pictures. Okay, these actually look a little bit better, so here we go. Wow, that's actually a beautiful shot. Okay, that's a lot better looking. So here we go. So this shark is like, I can't tell if that's like a black and white image or if that's like an actually like all black species. That's really cool. Again, the spiracle is really large. Again, you can see the steadily increasing size of the gills, which is really, really still a weird feature. You can actually see how big the teeth are proportional to the jaw, so that it's got a kind of spooky looking little smile. Very large eyes, which makes sense, very appropriate for its deep water habitat. And then like a couple, I can't tell if this is like scale damage or if this might be light spotting as far as the color pattern. Same here, if you, oh shoot, I can't zoom in there. Same here as far as like you could see like a dark, like velvety kind of look around the eye, the base or the bottom of the pectoral fins and the lower jaw, but then the surface looks like it's a bit of a rougher texture. So can't tell if that's preservation damage or if that might be part of the actual coloration of the species. And then here's a great shot of the teeth, and yeah, these are the lower teeth. So you can definitely tell that these large, broad teeth that are kind of in the belt are the lower teeth. So I think this is probably, I'm gonna guess this is probably like the kitefin shark, where these teeth are probably shed, all in one block, just because they're interlocking. But yeah, that's actually a really nasty set of teeth, given the size of this little shark. So small but mighty. So you can clearly see the dermal denticles, some of the spikes right here in this high resolution image. So that looks really cool, and you can actually see proportionally just how large the jaws are. Here's close-up. I'm assuming this is probably a very small individual, but a close-up of these teeth here. So the lower teeth on the bottom, the upper teeth on the top. The upper teeth are very long, narrow, and spiky. The lower teeth a bit more blade-like. Here's a better view of that. You can kind of see how those lower blade-like teeth interlock with each other. The upper teeth are more freeform. Howard, that looked insane. Hey, Yellow Ring, what's up? Welcome. I finally made it to Dr. Jaw's stream. Long time no see. What's up? Yeah. What's up, man? Welcome. Glad to have you. We're talking about the Taillight Shark. Taillight Shark. So this is um, um, uh, a new well, I guess not new, but it's kind of like a new deep water species, or like a new on this channel, a new kind of bioluminescent shark. Yellow Ring, I think I know who you are. Do you happen to do poetry and enjoy Pokemon just like I do? Let me know if you do. I think, and if I think I know who you are. I'm pretty sure I know who you are. And if I'm pretty sure I know who you are, and it's good to see you. Welcome. So, but speaking of Pokemon, there's a new game coming out that I'm kind of excited for. It's it's back in the Kalos region, so it's like the French Pokemon, and it has Mega Evolutions. I'm very excited about that. So this is kind of an interesting feature related to. Yay! What's up, man? Welcome back. It's good to see you. So fun fact for the chat. So Yellow Ring 11 is a really cool person. We went to school together. So but yeah. Please let me know. Phone is the same. So it's good to hear from you, man. So but this feature right here. So this is we're looking at the cloaca area of a male. But the reason this feature is highlighted is apparently this shark species has bioluminescence in this area that is unique to this area and unlike any other shark species. And I wonder if maybe, like, because this is kind of being pried open, I wonder if maybe this kind of shark emits bioluminescent fluid, just like the pocket shark. Pocket shark emits bioluminescent fluid from the pockets or the orifices on the side of its body. This shark might do something similar, but from the cloaca. So we'll learn more about that as we learn more about the biology of the taillight shark. So, but yes, definitely agree. Howard, earlier you made the comment that looked insane. Yes, like just the teeth. I love this close up of the teeth and like just the idea again, like the idea of the shark potentially shedding those teeth and acting like the kitefin shark, where the kitefin sharks will shed their teeth and ingest them, is just like really like ooh, just really creepy. So hopefully as we go through the footage we'll learn more about it and see and verify if that's a thing. But before we do, we'll take a look as always at the IUCN Red List and see how the shark is doing. So starting with the status of least concern. So taillight sharks are actually doing okay. It's always heartwarming to see that a shark is actually doing okay in this world of a lot of human activity. And that's one of my favorite things kind of about the channel and about our stream is that we have seen a lot of sharks that are critically endangered, and we have seen a lot of sharks that really do need our help. But we've also seen a lot of sharks that are still okay, that actually seem to be resisting fishing pressure well enough, and these are usually small sharks or deep water sharks that their biology allows them to reproduce more quickly or otherwise be of no interest to commercial fishing or even bycatch, or otherwise be able to evade it. So and it's nice to see that this shark seems to be one of the fortunately many that are least concerned. So yeah, absolutely. So it's a relief that shark species is doing perfectly fine. And yeah, I just saw the comment, bioluminescent groin, surrealistic. Yeah, it's so. Another thing I love is learning. We're on stream 88, but there's still unique sharks. Like no two species are quite the same, and it's beyond like the classic definition of species. It's also like they actually have very distinct modes of living. Like there's sharks that do things that I didn't even realize sharks could do. So, and it's kind of cool to see with the taillight shark, this is one of them. So the taillight shark is an extremely rare small oceanic shark with a patchy distribution. Specimens have been collected in the southwest Atlantic off Brazil in international waters, and in the southeast Atlantic off South Africa, and in the southeast Pacific off Chile, but is likely to occur more widely in these oceans. The species is known from only 4 specimens. Okay, so this is actually a lot rarer than I thought. And further research is needed on distribution, including habitat and life history. Interactions with fisheries appear to be minimal due to its small size, pelagic habitat, and overall limited catchability. There are no other known threats, and the population trend is suspected to be stable. The taillight shark is therefore assessed as least concern. Okay, so great to see. We'll scan this to see if there's anything on biology. Habitat. The taillight shark is a very poorly known oceanic species known from only 4 specimens. Pelagic trawl, bottom trawl. The depth of capture is erroneously reported 0 to 25 meters, and subsequently in the literature. Two of the known specimens are immature females, which was erroneously reported as a mature male. Okay. Reproduction is assumed to be lithotrophic viviparous. Interesting. Okay. Not much else on the species. So I think what we'll do as we go through the literature is we'll keep it broad enough to include other bioluminescent sharks, because I have a feeling there's just not going to be a lot on the species. And we'll see what we find. So I think this is the very first description. It's actually really cool to see this. Euprotomicroides zantedeschia, a new genus and species of pygmy Taillight shark from South Africa. Here we go. Okay, that's the shortest abstract I've ever seen. This is by P.A. Hulley and M.J. Penrith. A small Taillight shark trawled off the west coast of South Africa in about 300 fathoms is described and assigned to a new genus and species. By the way, fathoms drive me nuts because let's just do that conversion really quick. Fathoms to meters. Because fathoms are just about 2 meters, but they're not quite. So it's a measurement that drives me really, really nuts. So that's 549 meters. So that's right in the middle of the Twilight Zone. But fathoms, I just think it's a strange measurement because I don't even know. I don't even know. Yeah, single sentence is the shortest abstract. Yeah. Let's see. We're just gonna skim through the rest. Very small shark that was preliminarily identified as Heteroscymoides marlii. Okay. Oh, okay. This is kind of cool. I guess I'll reread that. Among the large quantity of material donated to the South African Museum during 1963 by the Cape Town trawler Aram. Oh, so this is where it got its name from. They were talking about on Fishbase how zantedeschia is related to the ship Aram. There we go. So it was a single example of a very small shark that was preliminarily identified as Heteroscymoides marlii. On re-examination, however, it was found that the little shark's preliminary identification was incorrect, and it could not be placed in any of the known Taillight genera. Okay, this is cool. That's actually really fun where, and I had to do this a little bit, and I never found a new species, but there are fisheries collections where you would do a huge round of sampling, and then you would take the fish back to the lab and identify them. So I would do that for freshwater fish. Like sharks I would voluntarily recatalog, but freshwater fish are the ones that I would do like I would get batches of freshwater fish and try to classify them correctly. But it's kind of cool that those kind of methods can be useful for this very reason, where you can look at something, look at an individual, and then realize, oh wait, there's something about this that looks different. The features look really different. This feels off. This is not the same kind of shark that we, thought we had, which is really cool. So, let's see. The present specimen differs as much from any of the known genera as they do from each other, and it seems necessary to define another monotypic genus. Okay, this is cool. Alright, so Euprotomicroides, brand new genus. A genus of Taillight Shark that can be distinguished from all others by the following combination of characters. So no spines, large gill slits, gill slits large, the largest about equal to the base of the fifth dorsal fin. No subterminal notch and caudal fin. Caudal fin lacking subterminal notch or precaudal pit. Teeth dissimilar in the two jaws. The genus resembles Euprotomicroides in general shape, but differs in having a more robust body, the dorsal fins of more equal size, and larger gill slits. Okay. Diagnosis for the new species. Gill openings large, vertical, arranged in horizontal series. So this is like the, it's like the gill slits as you go down the body get larger and larger. Oh yeah, there you go. Length of gill slits increase in size from the first to the fifth. The first 1.7, first 0.5 horizontal diameter eye. We don't need to get into the nitty gritty with measurements. I'm just kind of scanning through this. Oh, this is cool. Teeth. So you have 13 in the upper jaw, one symphysial, or symphysis. So the symphysis is the middle tooth connecting the two regions of the jaws. So 13 upper teeth on each side, 18 lower teeth on each side. Okay, don't need to go through everything here. I'm just kind of scanning through. Mouth broad and arch. Its width about equal to preoral length of snout. Preoral cavity is long, deeply incised. Upper teeth simple, erect, needle-like, arranged in regular posterior rows. 2 rows functional. That's cool. So the first 2 rows of the needle-like teeth of the upper jaw are functional. So that's actually, for a little fish, that's really creepy. Oh, hey, no worries. Good, glad to see you, Yellow Ring. Sorry, I just saw your comment. Oh, actually, hold on. Aren't fathoms an imperial unit? It probably is. Oh, Howard, how about leagues? Yep. Yellow Ring, was good to see you again as well. Thank you for joining. Yeah, we'll catch up soon. I am actually curious about that too. Leagues to fathoms. A league is... Oh! So a league is huge. So 1 league is 3,000 fathoms. Let's do meters. Can we do meters? A league... That's amazing. A league is... 5,000 meters. So that's... Wait a minute. Isn't it the novel 20,000 Leagues Under the Sea? So that's actually impossible, isn't it? 20,000 leagues under the... I never thought about that before. Hold on. Is that correct? That's actually ridiculous. I kind of love how ridiculous that is. 20,000 Leagues Under the Sea? It's 20,000 Leagues Under the Sea, isn't it? That's impossible. That's... How many of that kilometers is that? Oh my goodness. Hold on. 111,000 kilometers under the sea. I mean, for scale, like, the deepest trench is, am I doing this right? 11,000, that 11,000 meters is the deepest, well, yeah, okay, hold on. Mariana Trench. Sorry, this is fascinating right now. This. Okay, so the deepest point in the ocean is the Mariana Trench. The maximum depth is about 11,000 meters. There you go. So 11,000 meters, give or take. So leagues are ridiculous. So 20,000 leagues under the sea, I mean, you know, not a big deal because it's all fictional silliness anyway. But that's just that I didn't realize how absurd that was. So yeah, that's impossibly huge. Okay, so forget that. It should be 20,000. I don't know. I guess you would say 20,000 feet under the sea. Whoop, sorry, didn't mean to click that. That's the preview to my novel. Sorry about that. But yeah, interesting. Even though the lower teeth are wider than the uppers, there are still more of them. Ancient mariner slang, very nice. Yeah, it's so funny. Let's see. So, getting back to the shark. Wait, actually, yeah, interesting. Even though the lower teeth are wider than the uppers, there's still more of them. Yeah, actually, good point, Howard. Sorry, yeah. So that's sorry. It took me a minute to process that. So yeah, because the upper teeth are very small, but there's only 13 in the upper jaw, and then so it kind of almost seems like the lower jaw is a little bit like underslung a little bit. Like maybe it's a bit larger than the upper jaw in a weird way, like all those teeth packed in. See. Lower teeth, blade-like, smooth edge with high triangular cusp. Each cusp, except median, slightly oblique and notched laterally where cusp joins base. Teeth at angle jaw smaller, more oblique, and more acutely notched than those medially placed. A single series of teeth functional, with the base of the median tooth overlapping the base of the first tooth on each side, and the base of each adjacent tooth similarly overlapping with its lateral neighbor. Huh. It's a very good observation that there's more lower teeth than upper teeth, even though the lower teeth are larger. Oh, and this is the original description. So this is the same illustration from Shark References. So it's interesting that Shark References pulled it from the very first description of the species. Here are the dermal denticles. Actually really pretty looking, kind of like leaf-like scales, which is, as far as most sharks that we've seen, kind of unusual. Most sharks have kind of like the rivulets, like the kind of ridges that help them move through the water and cut through the water. But it's kind of cool to see these leaf-like scales. I think that's called lanceolate form for the dermal denticles. Oh, interesting. For males, claspers large, extending beyond posterior tip of pelvic fin. Inner margins orange colored. Okay. That is interesting. I've never heard of the color orange with a shark, actually. So, hmm. The name is derived from Zantedeschia aethiopica, the South African arum lily, after which the trawler arum was named. So that's a really unique name. That's pretty cool. Not a very good descriptive name, but I like the story behind it. Hmm. Okay, summary of this little relationship section. This is saying that because of the teeth, this shark falls well within the range of the Delaciidae, so these are the kitefin sharks, which makes sense. I've been mentioning kitefin shark a couple times because the teeth do look quite similar. Delacius licca, the classic kitefin shark, those teeth look a lot like that. So, let's see. Euprotomicroides, so our taillight shark, contrast from the cookie cutter shark and Delacius in that there's no subterminal notch in the caudal. Relative position of the dorsal fins are different. Lower teeth are not serrated as they are in Delacius. Oh, interesting. And the gill slits are larger. Interesting. It's kind of cool seeing, we won't go through all of it, but it's kind of cool seeing that there's a lot of justification for why that shark is just so different from the other species, from the other kinds. Oh, interesting. How I just saw your comment. They also use cables to measure surface distance on the ocean. Interesting. I would call the lower dentition imbricate. Imbricate. Very cool. Very, very cool. Now I'm interested in this, by the way. cable 2 meters. Or cable 2 leagues. So cable is much smaller than leagues, but cable to kilometers. I was having trouble with Fahrenheit versus Celsius one day, and I can't remember. Just kind of curious. 1 kilometer is 5 cables. Okay, so cables seem kind of small. Interesting. I was having trouble with Fahrenheit. I was making my girlfriend a tart from a British recipe, and it was using like grams and Celsius, and I had to like do the conversion to like cups in American and Fahrenheit in American, and boy, did it screw it up! I overloaded that tart with it's supposed to be like a savory tart with like red onion and brie and prosciutto, so it tastes really good, but like, oh my gosh, it was exploding with onions. That thing was insane. So like, measurements matter, and my girlfriend correctly reminded me that she suggested I get a scale to measure the grams, and I was like, oh, I'll figure it out. I'll convert it. It'll be fine. It was not fine. It was exploding. It was ridiculous. So measurements matter. And another case where like I really wish the United States got off its bizarre, strange, meaningless measurements to adopt the metric system. I really wish we had the metric system. It would make life so much easier. But I guess we want to be different. So, oh my goodness. Ecology. Okay, here we go. The small specimens in the species Taillight appear to be pelagic sharks, and in general are either known from only a single record or from several widely scattered localities. It is not known what the normal habitat of Euprotomicroides is, but it is very likely that it is an open bathypelagic dweller. Its depth of capture is not known. The bottom trawl in which it was caught was fishing about 250 to 350 fathoms, so right in the Twilight Zone. But whether it was caught... Oh, sorry, fathoms... sorry, that threw me off. That's still Twilight Zone, I think. Yeah, fathoms to... Because that's about 2 meters. So yeah, fathoms are about 2 meters. So still right smack dab in the middle of the Twilight Zone. But whether it was caught at that depth or at a lesser depth while setting or hauling the trawl is unknown. The head and skin are braided away in places, but this is likely to be due to the rough treatment it received in the trawl and on deck. Oh, that's a shame. So, but... Oh, cool. Howard, I think it refers to the length of the rigging. Got you. Yeah, my first thought was like the underwater cables, which I didn't realize how extensive they were, but underwater cables are so predominant around the world. So we're gonna, the rest is gonna be a mix of full papers and abstracts, but here we go. This one's just an abstract. Putatively luminous tissue in the abdominal pouch of a male dilatine shark, Euprotomicroides zantedeschia. This is by Ole Monk, Jorgen Morup, Jorgensen. So, the putatively luminous villous tissue in an abdominal pouch of a male specimen of the oceanic midwater shark, Euprotomicroides zantedeschia, is described. The epithelium within the pouch is probably stratified. The most conspicuous cell type is tall columnar cells, typically containing small cytoplasmic granules and a large inclusion. Cells with similar cytoplasmic characteristics thought to be photogenic cells are present in the epidermal skin photophores and other slakians, which are known to be luminous. Okay, so that was a long way of saying that this photograph does serve a purpose, indicating that this is actually possibly luminous. So this possibly gives off a bioluminescent light. And it looks like it's in the tissues itself, so the idea of this maybe secreting fluid, we don't really know how likely that is yet, so we'll keep reading to see if we have any more insights. Is this the same thing? Oh, this is the same thing. My apologies. Let me Get that out of here. Okay. This is a little bit of an older book on lots of different sharks, including the Taillight Shark, Euprotomicroides zantedeschia. So here we go. I don't think this is... Yeah, this is a different species right here. Oh, okay. Alright. Dr. Campagno found that the supposed claspers are actually the enlarged lips of the cloaca. Interesting. So this might be talking about how there was a misidentification of the species, like a misgendering of the species, like, or I guess missexing of the species. It was originally thought to be male, but this actually might be a female individual. Because I think it was Fishbase talking. It was either Fishbase or IUCN was talking about that. Here are two different lantern sharks. These are classic lantern sharks here. And then here is our shark, the Taillight Shark, Euprotomicroides zantedeschia. It's kind of cool to compare with a lantern shark. Lantern sharks definitely a lot slimmer looking, and they have these like really large spines. Again, the Taillight Shark doesn't have any spines. It is a lot stockier looking, and the gill slits look so different, whereas the lantern shark has like maybe slightly decreasing gill slit series, but relatively the same size. The Taillight Shark has an increasing gill slit series, and the teeth look so different too. The lowers are still in the belt, just like the lantern shark, but the Taillight Shark's lowers are a lot sharper looking and a lot more vertical, like a lot more erect looking. So the spiracle on the Taillight Shark is actually a lot larger as well. So kind of cool to compare these two. So. Howard, so when they mate, it's like a disco light show. Oh my gosh, maybe possibly that's one way to do it. So that I've never heard of a feature like this for any kind of shark. So I hope as the literature continues, we shed some light, pun intended, on the species. So here's a new one. Distribution of offshore demersal cartilaginous fish of the west coast of South Africa. Number of species recorded per 50 meters of depth. Oh, okay, I see. Oh, this is cool, actually. Ooh, this is a really cool breakdown. Okay. So, offshore benthic chondrichthyans from the west coast of southern Africa, collected on Africana cruises and listed by depth range in 50-meter increments in taxonomic order of text. So, this is super cool. This is a fun breakdown of habitat by depth. So, you have a list of sharks here. I'll shout out some favorites. Or familiar species, and we can kind of get an idea. Okay, we can kind of get an idea of as we go deeper and deeper who's populating what zone. So this is an older study, but this is actually a really cool breakdown. So, firstly, let's try to find our species, Euprotomicroides. Who should be listed here, but I'm not seeing him actually. I'll go back to that. It should be in this study. I promise I will definitely go back to that because that's just too cool. I definitely want to check that out more. Centrophorus, so it's the gulper shark. Centroskillium, Portuguese dogfish, Diania, arrowhead dogfish, Hemopterus, we're getting closer, Hemopterus, There we go. Okay, Euprotomicroides and zantedeschia. Figures 1 through 4. Oh, this is just a list of records. Oh, okay. The Taillight Shark is currently known from only 2 specimens from the South Atlantic. The first was collected in a bottom trawl on the continental slope off Cape Town, and the second was caught in a pelagic trawl near the surface in oceanic waters east of Uruguay. No material of the species turned up in Africana bottom trawls in the area, nor was it caught in epibenthic pelagic trawls during cruise 60 off the Western Cape. It could be an epipelagic or mesopelagic species that was accidentally caught on or near the bottom of Cape Town and not a shark of the deep slopes. Interesting. So it was not found in this study, but it is a shark that has been seen in this area. So, cool. Now, going back to this study, I do want to see that really cool distribution record of sharks by depth. So here we go. Okay. Let's start here. We'll start above 200 meters is the sunlit zone. Let's see if there's any sharks. There are actually quite a few sharks that like the sunlit zone. Oh, there we go. Squalus acanthius, so it's the pike dogfish or spiny dogfish. So classic dogfish like the sunlit zone. We've got Hola hyluris. So this is a cat shark, if I'm not mistaken. Yep, this is a kind of cat shark. This might be the Eddie, like the Happy Eddie, or the Isaac, or a shy shark. I think that's that genus. And then Raja is a ray. Calorhynchus, I'm not sure what that is. That's definitely not a shark. That is either a ray or a chimera. I'm assuming it's a ray. But, okay. Then when you go deeper, this other half of the list here is the Twilight Zone. Still getting some dogfish. Getting a few sparse records of some of these deep water sharks. So you got the arrowhead dogfish, some lantern sharks. Now you're getting a concentration of rays. So some of these deep water, these Rajas are all rays. Okay. And then this is cool. When you get deeper and deeper, up to 1,000 meters, this is the deeper half of the Twilight Zone. What's this row? The first couple rows, Centroschimus. So, okay, so these are like some of the, I think Centroschimus is the black dogfish, Centrophorus is the gulper shark, Hexanchus is a six-gill shark, Chlamydostylacus is a frilled shark. So, this is a really cool study, like a really cool breakdown of shark distribution in the different zones, as well as rays and chimeras, so pretty cool. We'll keep learning more about our species. Ooh, Howard, good observation. It really resembles a pygmy shark. Okay, list of deep sea sharks occurring in the area. Oh, this is cool. So this is, I think, a guide of deep sea cartilaginous fishes of southeastern Atlantic. So the list of deep sea sharks are R-shark, Euprotomicroides, Heteroschimus, and Isistius. Isistius is a cookie cutter shark. The other two, I think, are kinds of lantern sharks. But this is actually a really cool example of a dichotomous key. So this is showing features to look for. Here we go. Actually, that's a great illustration. So features to look for. Gill openings increasing in width posteriorly. The fifth very wide, so right here you can see that. Pectoral fin, inner margin, inferior tip greatly expanded and lobate. Second dorsal fin origin anterior to pectoral fin origins. Cloaca greatly expanded as a luminous gland with yellow papillae within it. Interesting. Okay. So again, it's showing that this is actually a really important feature, and this is a identifying feature for taillight sharks. Gotcha. So it's not very subtle, apparently, in living individuals. So this is a beautiful illustration of the species, and you can more clearly see some nuances in the color pattern. including like this nice like striping on the back, along with this like speckle pattern. You can see just how large the mouth is related to the body size. Again, it really does remind me a little bit of sperm whales, where you have like that, kind of squared off round, this rounded kind of squarish looking shape as far as the snout goes, but then the underslung jaw and then the lower teeth are going to be very large, and then you have also like the paddle shaped fins. It's really cool. It's a really nice. I love that illustration. It's actually a really nice illustration. But dichotomous keys, really cool to kind of use to identify sharks. So you either, if you have a shark in front of you, you apply the key to them, where you say, okay, does it have these features, or does it have a different set of features? And if we had a taillight shark, we would identify the genus correctly. But if we didn't, we would have to go to 1B, which will, the answer to that will take us to key 2, and then we have to further classify it, reading key 2 and comparing these two answers. So it's really cool. It's kind of like choose your own adventure. I really like dichotomous keys. Alright, so let's keep reading. Oh, here we go. Euprotomicroides. So far we have not read... Oh, there we go. I was about to say we've not read an English name, but here we go. Local names, taillight sharks. All right, we won't read all of this verbatim, just because this is just diagnostic features, so we already kind of know what the shark looks like. The color is blackish brown with conspicuous light fin margins. Again, the cloaca greatly expanded, modified as a luminous gland. With secretory papillae. Okay, so that indicates that maybe the shark excretes a fluid that is bioluminescent. Oh, this is interesting. There actually might be two taillight sharks. Listen to this. A specimen of this genus, only the third known, was recently collected by a trawler in the South Pacific and may represent a new species within the genus, as this most recent specimen differs morphologically from Euprotomicroides zantedeschia. Wow, okay. Interesting. Here's a more detailed account of the taillight shark Euprotomicroides zantedeschia. Here we go. Again, love that illustration. It's really beautiful. Really, really great drawing. Conical, moderately long, blunt, compressed snout, needle-like upper teeth and blade-like lowers, compressed body, gill slits increasing greatly in size from front to back, lobate chimera-like pectoral fins. That's an interesting observation, chimera-like. So that's actually, I've never read that. I've never seen that as far as a feature to describe a shark's fins, chimera-like. So chimeras, as we know, are cousins of sharks. They're very strange looking actually, because they almost look like the middle step between a shark and a bony fish. They have gill coverings, but they also are cartilaginous fish. So. But that's interesting that the fins resemble chimeras. Mid-ventral keel and caudal peduncle. No dorsal fin spines. No anal fin. Asymmetric caudal fin. Cloacal gland dark color conspicuous in fin margins. Love these light bands on the back. Love these nuances in this illustration. A little known, extraordinarily specialized oceanic dwarf shark. Known from only two specimens. One was called offshore, second was captured near surface. Motor known, probably viviparous. Okay, I don't know about that. It seems a little dubious. The cloak of the shark is barely expanded into a gland with internal villi that secrete. Oh, there we go. Okay, so confirmed. It does secrete bioluminescent blue fluid, just like the pocket shark. Very cool. The cloaca of the shark is greatly expanded into a gland with internal villi that secretes a blue, luminous substance. The broadly lobate muscular-based pectoral fin situated on the compressed body in a position similar to pectoral fins of chimeras suggests that pectoral propulsion, or at least pectoral hovering, is important in this shark. Okay, so that's kind of like That's interesting. So that's suggesting that the shark is swimming almost like a bony fish, almost like most sharks, if not all sharks, they swim mostly by their caudal fins, like their tail fins, pushing them forward. But it's kind of interesting that the pectoral fins being so large might be helping this particular species hover in the water column, which is kind of unusual. It's really cool to see that. Or the shark might be flapping its pectoral fins to move, which I think it's got to be a combination of like maybe flapping the pectoral fins and moving the caudal fin, because the caudal fin is really large. It does look like, relative to the body size, a pretty effective fin to help the shark move. So. Food unknown. The powerful jaws and sharp lower teeth suggest that this species can capture and dismember relatively large prey. We already got the length. No interest of fisheries. And that's really it. So, but that's already an improvement on information. It's pretty interesting. So, oh, thank you, Howard. I just saw your comment. Good guess. Thank you. So, probably to lure prey using bioluminescence. Yes. So that you're probably right. Actually, probably a way to lure prey. I wonder also, maybe because it is so close to the cloaca, is this also a mechanism for attracting mates potentially? So I'm not sure, but let's see. Here is Deep Sea Carlange's Fishes in the Southeastern Pacific Ocean by David A. Ebert, very famous shark scientist. Probably recognize him from Discovery Channel specials, but he's done a lot of great literature. He's actually very prominent in the literature. Let's see. I think this is a similar kind of field guide. It probably has the same information, actually. This is not the same guide, but this is a similar guide. This is also an FAO guide, so we'll kind of read on and see if there's anything new. Let's see. Oh, okay. A little bit of details. Two specimens from the Juan Fernandez Islands, Chile. Both specimens were caught in midwater trawls. One was at a depth of 75 meters during the daytime. The southeastern Atlantic specimen was caught offshore on the continental slope in a bottom trawl. Okay. This is an interesting note. So it's the same one we saw earlier. The cloaca of the shark is greatly expanded into a gland with internal villi that secrete a blue luminous substance. This will be reported in detail elsewhere. That's an interesting little note. So I guess maybe Ebert published a paper about this, and hopefully it's one of ours later tonight. Okay, so a couple little new notes, but nothing too major. Okay, here we go. So this is a figure of the taillight shark cells. So secretory luminous tissue of Euprotomicroides zantedeschia. Data from 35. BL is basilamia. C is a columnar cell. CT is connective tissue. F is a flattened cell. N is the nucleus. S is superficial cell. V is vesicle, presumed to be photogenic. Okay. Bar scales, 50 micrometers. Okay. So these are three types of cells all squished together. So you have these white cells are, where are these again? These superficial cells. So these are at the surface. These gray cells are columnar cells. And then the dark gray cells are flattened cells. And then the vesicles here presumed to be photogenic. I'm assuming this is where bioluminescence can be found. It's kind of cool to see, like, at a cellular level, there's 3 types of cells working together in the in that luminous region on the shark's body. And here we go. Here's the section on this. Secretory luminous tissues. In Euprotomicroides zantedeschia, so the taillight shark, a putatively luminous tissue of another type has been found. This tissue is a probably stratified epithelium present into the abdominal pouch of the species, with a thickness of 50 to 75 micrometers. It is composed of different cell types, columnar cells possessing one huge yellow apical inclusion, as well as a basal nucleus. Okay, so I think V is the apical inclusion, so this is the yellow area, and then there's the nucleus in the bottom. 2 flattened cells with basal nucleus extend from the basal lamina towards the free surface of the epithelium, separating the lateral cell membranes of tall columnar cells, and then superficial cells with a nucleus close to the surface of the epithelium, and a very thin cover over the dome-shaped distal surfaces of columnar cells. A tissue of this kind may also exist in the pectoral gland of M. perinnei. So this is Mollusquama perinnei, the I'm losing it. Like, I literally was talking about it earlier. Pocket shark. There we go. Pocket shark. So this is, they're saying that the taillight shark and the pocket shark have similar tissues. So, okay. Okay. 35. I wonder if this document has photographs. Okay. It does. So let's see. I'm just kind of scanning through to find our shark. But this is a really cool bioluminescent study. Ooh. This is so cool. Bioluminescent sharks are really so cool. What? Oh. Let's go back up here. We've seen a similar study like this before, so this is showing the evolution of bioluminescence. There's a new study that we've seen a lot that has an updated version of this, showing the presence and absence of bioluminescence in sharks. Okay, now this is really cool. This is actually extremely cool. So this is a really interesting chart of sharks by depth on the left side. So 1 meters, 10 meters, 100 meters, 1,000 meters. Length on the right side. The white circles are non-luminous sharks. So these are most sharks that we're familiar with, and almost all the large sharks are not luminous. Then the gray ones are Euprotomicroides. These are the lantern sharks. And then the black ones are Taillight, the kitefin sharks, like our taillight shark is a kitefin shark. And you can easily see how when you're a shark that lives deeper in depth and tend to be on the smaller side, bioluminescence is kind of more handy and more prevalent. So it's actually kind of cool to see that. Larger sharks don't really seem to have a need for it as much, and sharks that live on the surface, regardless of their size, don't really seem to need it at all, which makes sense. But very cool to see. And here is kind of a guide on bioluminescence. Trigonanathus is the viper dogfish. Centroscalium, I believe, is the black dogfish, where you only have a little thin layer of bioluminescence. The viper dogfish has a lot of it. I'm not sure what Aculeola is. Amopterus is a classic lantern shark. Molluscum is the pocket shark right here. Euprotomicroides. Oh, look at that. So that's actually really interesting. So the pocket shark and the taillight shark, they're actually suspected to be closely related, which makes sense because these two sharks seem to excrete bioluminescent fluid. That's actually really cool that that feature is shared between them, and that there's also an inference that these two are actually closely related. So it could be maybe a shared derived trait, making them monophyletic. So that's actually really cool. Oh, Howard, do they explain it is related to what sharks eat? For example, bioluminescent jellyfish. Ooh, that's a good question. I don't know. Let's see if we can find that. I think we'll read the abstract and then we'll kind of scan through to see, just in general, the mechanism of bioluminescence. So, bioluminescence of sharks, first synthesis. This is by J.M. Kleis and J. Malafet. This work gives a state-of-the-art synthesis on shark luminescence. We present information on the different luminescent sharks, their luminous patterns, the histological organization of their photogenic organs, their specialized squamation, and the characteristics and putative functions of their bioluminescence. We illustrate differences between the two families of luminescent sharks and give a hypothesis for the bioluminescence acquisition in these two groups. We also highlight the limitations of our current knowledge of these luminous organisms. Finally, recent discoveries on one model species, the velvet-bellied lantern shark, Amatra spinax, are being presented. Very cool. Okay, so we'll kind of scan through this. I'm just going to take a sip of my... Still have some coffee left, so... In the deep sea, many organisms, from bacteria to fishes, possess structure to emit light. In this dark environment, which offers no place to hide and only rare meals, bioluminescence assumes numerous functions, including predation, defense against predators, and reproduction. While the majority of deep-sea bony fish are luminous, only a small fraction of deep-sea chondrichthyans is endowed with this capability. This led some authors to consider this amazing property like a burden in these fishes. Even though it was absent in chimeras, luminescence competence nevertheless appeared in at least 3 times independently in cartilaginous fishes, once in rays and twice in squalene sharks. Thus, a total of at least 51 cartilaginous species are involved. Luminescent sharks have been poorly investigated. This explains why only extremely limited and fragmented information is available in the literature on shark bioluminescence. This is a really cool study. This paper aims to provide the first synthesis on what is currently known on the phenomenon of visible light emission in these cartilaginous fishes. Actually, Howard, I just saw your comment. Most papers are really like they have that paywall, but some are publicly available, including this one. So I'm gonna just share the link with you. So you can read it more in detail later, and we'll go through it together here too. But there's the paper, and this is called "Bioluminescence of Sharks' First Synthesis." I wonder if I could just. Oh no! Go back! Okay, because you can just click open PDF, and you don't need to be logged into anything, or I don't think you need to pay anything for that. It's right there, which is really cool. I really love and completely support publicly available information as far as science goes. Just because it's knowledge for us all. I really think that's kind of the purest iteration of knowledge. I think it's really cool. So I know the paywalls are there to kind of support research and everything, but they're also controversial within the scientific community. A lot of scientists do not like them, as far as they want to share knowledge with the world, but also easily access knowledge themselves through their own research if they're doing primary research, or I guess it's secondary research if they're pulling papers. So because primary research is actually doing experiments, and then secondary research is kind of doing research like this. But the paywall is a very controversial subject, even in the scientific community. Some scientists do not want it at all because knowledge is for everybody. So, and I really like that philosophy personally. So, luminescent sharks. I'm curious. Okay. Oh, here we go, Howard. This is cool. Symbiotic luminescence. In symbiotic luminescence, the light production is only present through the association with another organism which is luminous. This is frequently observed in deep sea squids and bony fish harboring bacterial photophores. This has been found for some shark species. The mouth of the megamouth shark, Megachasma pelagios, which we did see, was considered to be a bacteria-filled luminous lure, allowing krill attraction, and ocular parasitic copepods of sleeper sharks were thought to... Okay, so yeah, like the Greenland sleeper shark, that creepy parasite on its eye, thought to attract prey items to the mouth of the shark. Interesting. Oh, but now since any evidence to find luminescent tissues in the mouth of the megamouth failed, and since tested specimens of sleeper sharks' copepods were not luminous, symbiotic luminescence seemed to be very unlikely in these sharks. Okay. So what's this other one? Intrinsic bioluminescence appeared in two shark families, the lantern sharks and the... I personally call Taillight kitefin sharks, but they're calling them dwarf mesopelagic sharks. Let's see... The Homopteridae radiated 90 million years ago when they started to leave shallow water environments to occupy the empty deep water niches during their marine life turnover, which followed the mass extinction provoked by the global Cenomanian Turonian anoxic event. Interesting. So 90 million years ago is the Cretaceous period? Yes, it's a Cretaceous period. So... Oh, Howard, just saw your comment. Most of the ones I'm chasing dollars. Me too. It should be that way. Although I've enjoyed collecting all the material of scientific value, will be donated to a museum for further study. That's actually really cool. All the material of scientific value will be donated to a museum. Yeah, and if you're referring to the fossils, because I have my own fossil collection as well, and I think as long as the fossils are appreciated for what they are, it's really cool. It is really cool to donate them, and very valuable to do that, and actually arguably the right thing to do. But I also think, for me, I do want to keep my fossils for a very long time, as far as just, I understand what they are, and I love them, and I love being able to kind of show them to people and to teach people. So I think if you appreciate it for a private collection, if you have a deep understanding of what that is, and it's not like a trinket, it's like something that you genuinely value and care about, I do think it's kind of okay to kind of have your own private collection. And actually a lot of museums, at least in the days before public museums, a lot of them were actually founded by private collections of individuals, which is really cool. And it sounds like that's something you're interested in as well, which is really, really awesome and commendable. So, I see value in private collections, as far as they may be private now, but in the future they can be donated, like you said. And I think they're just really cool. I think people don't realize that maybe some of the most important museums in the world, including, I forget if it's the Natural History Museum in Washington or if it's a different kind of Smithsonian museum, but there is a museum that really started from the private collection of, I want to say it was, I might be mixing everything up, because I want to say it was William Penn. There was a very famous naturalist in the United States in the very early days who accumulated all these items and fossils and things from around the world, and eventually donated them to form basically the impetus of one of the natural, I guess the Natural Museum of Natural History. Let me look that up really quick, because I don't want to be making anything up. But is it William Penn? William Penn. It's not him. Is this a totally different person? Legacy. This might not be him. Okay. Something about Who am I thinking of? There's somebody I'm thinking. There's an American. Okay, it's not him. I'm sorry. Screw all that. It is not him. There is a famous American, and I can't think of who it is. Maybe he's from Pennsylvania, but there's a famous American who had a bunch of fossils, and he began one of the museums, and I cannot remember who it is. But private collections are important. Is what I'm trying to say. Like. Okay, I'm gonna look up Iguanodon really quick because I think he was the guy who found Iguanodon. Let me just make sure. Iguanodon, blah blah blah. Da 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 da. Blah 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 blah. Never mind. That's someone in England. Okay, I don't know what I'm talking about. I'm gonna move on to sharks. I'm just gonna stick with sharks. I don't know my history that well, so. Oh, Bruce, good point. Depend, and also welcome back. It depends on how rare that is, how scientifically important it is. That's true. That's a good point. My collection includes a large group of shark specimens from the same genus Hemipristis. Very, very cool. Yeah, and that collection is extremely cool. The snaggletooth sharks, the Hemipristis fossils, and other Hemipristis species. Good to see you too, Bruce. Good to see you too. My collection is Virginia or modern Virginia. Oh, sorry, I guess I can't say that. Like fossils from modern Virginia. So these would be fossils that are in the Miocene, Oligocene Miocene sharks from Virginia. And I think it's specifically the Yorktown Formation and St. Mary's Formation. But these are shark species that are pretty common in the area. I would say the rarest tooth I have is probably the giant white shark teeth, Carcharodon plicatellus, and Carcharodon histalis. Those are the two giant white shark teeth that I have. But those are not earth-shatteringly rare. But I mean, I think. I do have them cataloged correctly as far as like where they were found, like their provenience. So maybe in the future, if I do donate them, that will be a value for geologists as far as like their original locations are marked, so that kind of helps continue to paint the picture of what that environment was like years ago. But I love those teeth, and I really, really value them greatly as far as, I guess what I mean is, like, I appreciate the shark teeth, so I feel comfortable collecting them. I don't feel comfortable collecting shells because I don't understand them as well. Like the fossil shells, like Chesapecten, or, there's a really famous one from Maryland, Ecphora, there we go. And like I don't keep those because I don't feel as passionately about those, and like I know there's someone who loves marine mollusks who wants to find that fossil, so I leave them there. Also, in certain places you are not legally allowed to collect those. You're legally, for the most part, you're legally allowed to collect shark teeth because they're pretty, depending on where you are, they're pretty common. But I know mollusks, depending on where you are illegal. What's kind of funny is when I did like the fossil contest, and some of the winners, and Howard is one of the winners of a fossil contest. They don't live in the United States, so I have to do a customs form to ship them. And fossil shark teeth are totally fine. You can ship those, but fossil shells are like illegal to actually export from the United States, which is kind of interesting. You would think I feel like you would think it's the other way around, because I feel like the shells are very common and the sharks are much rarer. But yes, Howard, I definitely agree. I love holding something in my hands that's millions of years old. I completely agree with that. And also just think about like it's a marvel to think that was in the mouth of a shark. Like that was a part of a living, breathing millions of year old shark that use those teeth to find prey items. And if they're bigger teeth too, like that shark was a successful hunter, was able to grow, it's incredible to think about that that was part of that individual who lived in the time of dinosaurs and like depending on when you collect teeth, um, like Miocene. I'm trying to think of like Miocene era animals like predatory birds or some of the largest sharks in the world that have ever existed. It's just incredible to think about. That was that tooth that you have in your hand was once in an ocean millions of years ago, like just swimming around in the ocean. It's just such a cool thing. So yeah, mad respect for fossils. So, speaking of fossils and prehistoric sharks, it's actually really cool to read. The Euprotomicroides radiated 90 million years ago. Love reading about shark evolution. So the lantern sharks left shallow water environments and it occupied the deep water environments as kind of part of adaptive radiation, which is really cool. Oh, and this shark family encompasses 5 different genera. Achilleola, which I'm not that familiar with, Centroscilium, which is black dogfish, Amopterus, which are the classic lantern sharks, Microscilium, not very familiar with that, and Trigonognathus, the viper dogfish, which that was a really fun stream from last year. We did the viper dogfish. These are all luminous. The Taillight, which include the taillight shark, on the other hand, evolved later when they replaced extinct large fishes. Evolved later when they replaced extinct large fishes and marine reptiles in the epipelagic fauna of the Paleocene after the Cretaceous Paleocene mass extinction. So after the comet, or the meteor, I guess, 65 million years ago. 7 genera are present in this family. Delacius, which are the kitefin sharks. Euprotomicroides, which is the taillight shark. Euprotomicris, I'm not sure what that one is. Heteroscynoids, I'm not sure what that one is. Asistios, the cookie cutter sharks. Mollusquama, the pocket shark. And Squaliolus, not sure what that one is actually. Some of them are luminescent. Let's see. This is kind of a cool note because this was before we confirmed that pocket sharks were luminescent. They produce luminescence. While Amopteridae, the lantern sharks are demersal species, so they like to stick near the bottom, and they live in groups. I actually didn't know that. I didn't know that lantern sharks live in groups. All Delaciidae are essentially solitary pelagic predators which undergo daily vertical migrations. So most likely the taillight shark is probably swimming on its own. It's kind of cool. I don't see anything about how they're bioluminescent in terms of like, did they eat something that makes them glow, or is it actually generated from within them? Let's see. Okay, the structure of photophores on sharks are simpler than bony fish. So bioluminescent bony fish have more complicated structures than bioluminescent sharks. Interesting. Okay, we read this part of secretory luminous tissues. Okay. They're talking about what they glow as far as bluish, greenish glows, and this is really cool to see the underbelly of different sharks. So here's a shark. A lantern shark. You can see the jaw, the snout, the little pectoral fins, the collar of the lower jaw, the pelvic fins, and then the caudal fin here. Really, really cool. Control. Uh, there's a hypothesis that bioluminescence is in sharks hormonally controlled. A control via the iris-like structure of the photophores through the action of chromatophores and Euprotomicroides has sometimes been suggested but never tested. So there's nothing about how it accumulates bioluminescence. So I'm assuming it might not be the fact, like these sharks might not be eating bioluminescent organisms. They actually might be generating it themselves, which is really cool. Let's see if there's anything about our shark specifically. Okay. Well, actually, here's a different shark, but a different kind of lantern shark. But this might be talking about bioluminescence specifically, so I think it's worth a look. The elaboration of luminous structure occurs before birth. Fluorescent vesicles inside the photocytes. The luminous pattern of Euprotomicroides spinax, which is a kind of lantern shark, is fully operational before birth. Okay. There's a hypothesis that bioluminescence appeared 2 times independently in sharks. So it's not like a shared derived trait. It's something that has popped up a couple different times in shark evolution. Firstly, in Euprotomicroides, the lantern sharks, in response to the need of an efficient tool for species recognition in deep water environments. And secondly, the kitefin sharks, like our taillight shark, to provide an efficient camouflage in a pelagic environment with no place to hide. Okay, this is really cool. That was a really good study. So we'll move on to learn more about our taillight shark, but including this. But first, since it's oh hey Gabriel, welcome. Sorry I didn't see you there. Welcome to the stream. Yeah, just welcome. This is a really welcoming community. Everybody's really cool and chill, and they love sharks and love talking about sharks. So if you have any questions, please leave it in the chat. If you also love learning where everybody's from, we have Canadians, Americans, Indonesians so far. If you don't mind sharing what country or state you're from, please feel free to do that in the chat. And also in here, I'm from the East Coast of the United States, so it's 10:30 my time. So this is around the time we ask the audience if there's a specific kind of shark you want to cover for next week. So if you guys have a specific shark species for next week, please leave it in the chat. We've covered 88 species now already, but there's 514 sharks total, so there's a bunch left. So please leave any recommendations in the chat. And then Howard, the thing to be careful about association dentitions, if you start finding vertebrae clumped with teeth, take your time. Gotcha. Yep. Yeah, for fossils, yeah. Like, yeah, absolutely. Let's see. Redescription of the rare taillight shark, Euprotomicroides zantedeschia, based on a 3rd and 4th record from off Chile. Let's see. So this is from Matthias Stemmen, Marcian van Oygen, and Pepijn Kaminga. Kaminga is a name I'm familiar with, actually. So The third and fourth records of the rare oceanic delayed shark Euprotomicroides indicia are described. A nearly mature male was caught by a Russian trawler, and a presumably mature female by a Dutch stern trawler in 2008. Both new records of this rare species, hitherto known only from the juvenile female holotype from the southeast Atlantic and South Africa, and a mature male found off of Uruguay, are described and illustrated in detail. A comparison of the Chilean records with the former Atlantic ones confirmed conspecificity of all four so far known specimens. The unique generic diagnostic characters of a huge luminous abdominal pouch gland is illustrated with photographs. The likewise among sharks' unique pelvic girdle morphology is shown by commuted CT images. Okay, this is going to be really cool. Please tell me that these images are here. Okay. Alright, so these are brand new taillight shark images. Okay. You can see how big the snout is. Because these are the ones that we saw earlier, but these are very damaged individuals, so... you can I can kind of see in figure A maybe what they're talking about, where this area right here, I could see where that can be mistaken for a clasper, but this is really the enlarged tissue area that emits bioluminescent fluid. You can see the large underslung jaw. This is a really good looking individual right here. That's probably the freshest specimen we've seen. Let's see. And you can see the enlarged spiracle, the large second dorsal fin and pelvic fins, caudal fin. And mostly pretty uniform color on the body. I do want to see if there's any chance we can kind of get a look at. You can kind of barely see some of the striations that were in the illustration from that FAO guide, where they had those really cool spots and striations in the back. You can kind of see that barely here. This is like dark, oily color. Okay. And then this, I think, is the CT scan individual. Unless this is the illustrated individual. But here you go. You can see kind of the enlarged. Is this a female shark? Okay, so that is wild. So this is a female shark, but you can see like the enlarged cloaca area, and that does at first glance look like clasper. So that almost looks like the male feature of sharks. But the fact that this is so enlarged, that is unique among sharks in general, and that is a luminant. That is an organ that produces luminous fluid. That's so interesting. Let's see. Oh, more. Oh, these are actually pretty good. All right. Specifically these, so you can actually see like the needly upper teeth here, and it said in the paper double rows of teeth, and you can actually kind of see that function here. The bottom teeth look almost shed. They almost look like too uniform or broken off. This individual is pretty interesting because you can actually very clearly see on the left side the bottom teeth. Being upright. On the right side, it looks like they might have shed or broken off. So. And that could be damage from hauling up. So, ooh, Howard, broadnose seven-gill shark. Let's see if we covered that. That would be a really good one. I'm just double checking the Hexantiform playlist. We have not. Yeah, let's do it. Yeah, I would love to do that species. So, and that's a really cool one that's going to have a lot of footage, because that's like one of the unusually like shallow water sharks. So, as far as the unusually shallow water hexantiform sharks, like those big like cow sharks. So, all right, let's do it. So, broad-nose seven-gill shark. Okay, so that's going to be next week, Notorhynchus sepidianus. So that one is going to be awesome because that I know is a kind of shark that you can find in kelp forests in shallow water, and it's still one of those like really large, like really cool looking, like the seven-gill shark species, like that. That's going to be a lot of fun. So that's a really great suggestion. So I'm excited for next week. That will be next week's shark. So let's definitely do that. So thank you, Howard. All right. We have... usually we wrap up the stream around 11 East Coast time, so we'll spend the rest of our time looking up more about the taillight shark. This actually provided more information than I thought for tonight. Even though it's a rare shark, we're getting a lot more information about it, which is really exciting. So, nice close-up view of the dorsal fins, also of the teeth right here. Okay. And then this, okay, so this is where this photograph comes from. It's this study. Okay. So you can see the pigmentation, like the yellow pigmentation here. So in kind of like this fluid producing area. That is so unusual looking as far as like how large that is. You know, because that, like, most sharks don't have anything remotely looking like this, and the fact that this is a female shark, and the fact that like this area is so prominent, that, you know, I know it's probably kind of like strange to see, but that is I can't emphasize enough like how unique that is among sharks. Most sharks are much more streamlined looking, kind of in that pelvic fin area, but the fact that that's so enlarged, that's completely unique among sharks. So taillight shark is a really, like, there's no other shark that looks like it. Here are the CT scans. Three-dimensional view of the pelvic girdle. And we'll kind of read up on that. Very extraordinary shape of the pelvic girdle. I really do want to see kind of in a discuss. Oh, what is this? Okay, so it's kind of sad as far as like, and I don't want to really read how this was kind of like collected out loud, but this is visual confirmation of the bioluminescent fluid coming out of the shark, as far as like coming out of that enlarged pelvic area. So so this is the confirmation that the taillight shark is indeed bioluminescent. So it's one of, so far as I know, only two sharks that produce a kind of fluid, the other being the pocket shark. I do want to move forward to discussion. So, okay. Because this study is so comprehensive, I really want to see how they characterize the shark. So here we go. So obviously the taillight shark is an oceanic pelagic shark of the cookie cutter type, according to its dentition and inhabiting epi to mesopelagic depths and also far offshore. Its distribution may be much wider in the Atlantic and Pacific Oceans, possibly also in the Indian Ocean. Let's see. It appears to be rare and living rather solitarily, quite unlike the well-known, more common and schooling cookie cutter shark. However, the possession of the huge abdominal pouch gland capable of ejecting a light blue luminous fluid is unique among sharks and indicates that the taillight shark normally lives rather deep and or occurs at shallower depth only during nighttime when following the upward moving scattering layers for feeding. So far, the preferred prey is not yet known for sure, whether it's larger invertebrates such as squids, bony fishes, or marine mammals as in other cookie-cutter shark species. Oh, apparently, so radiographs from one of the taillight sharks depicted 4 relatively large circular items within the intestinal tract, which might be squid eye lenses. So that's a hint that this shark might be attacking squid or preying on squid. Dorsal fins are unequal shaped in most shark species, but may often differ in size. Among dilation sharks, however, there is found in several genera. The first was markedly different from the second dorsal fin. That's the case with Taillight Shark. There's a speculation that the taillight shark is sexually dimorphic, meaning that males and females look different, but it says that's speculative. Whether morphology of size of jaw, teeth, or size and density of dermal denticles, or even morphology of pelvic girdle are concerned. Okay. Alright, so this is a pretty new study. I think this was 2016, but it added a lot to, there's really wasn't a lot of research on this species, and this one added quite a bit. Okay, 2016, so this one actually added quite a bit. Oh, sorry about that. Sorry about the audio. Let me know if it improves. But yeah, this was actually a really, really great study on the taillight shark, providing more information. So the confirmation that it does, get out of here, I hate ads. Get out of here. Okay. The confirmation that it does emit the bioluminescent fluid, and also that reaffirmation that it's a solitary species, so it doesn't really school like the other, like cookie cutter sharks do. Let's see, deep water sharks of Brazil. Also a bunch of ads. Don't endorse any of this. Get out of here. Let's see where our shark comes up. I think it's just noted in Brazil, so we'll move on to a different study. Oh, here we go. This is the same FAO note on taillight sharks. So this is kind of more of like a classification guide. This really isn't more information on it, so we'll keep moving on. Okay, and I think this is the newest bioluminescent shark study. I think we've seen this one before. Glow on Sharks, state-of-the-art bioluminescent research. Okay, so we won't reread this one all the way through, and this might be the study that carries us home. Okay, yeah, because I think the rest are also familiar studies. So this is by Lornette Duchat Chatelet, I apologize if I'm not saying that correctly, Julian M. Claes, Jerome Del Rossi, Patrick Flaming, and Rome Malafet. So this review presents a synthesis of shark bioluminescent knowledge. Up-to-date bioluminescent sharks are only found in squaliforms, and specifically in lantern sharks, kitefin shark, and sleeper shark families. The state-of-the-art knowledge about the evolution, ecological functions, structure, and associated squamation and physiological control of the photogenic organs of these elusive deep-sea sharks is presented. So this is kind of like an updated version of the study that we saw already. So we'll just kind of move forward to notes on our species specifically, so the taillight shark. Let's see. Luminescents have been observed live in 15 species only, including the taillight shark. So this is part of that list. Photogenic structure is the pelvic pouch fluid. So look how unique it is amongst the other luminescent sharks. The luminescent color is dark blue. Notice how most of the other sharks are either blue, dark blue, blue-green, green, and whitish. That's really it on this species. Let me see if I... Oh, this is a really cool... I think we've seen this before, but this is a really cool cladogram of bioluminescent sharks. Oh, thanks, Howard. So audio is okay. Here we go. There he is. Okay, I see him. Alright, so Euprotomicroides zantedeschia, the taillight shark, is right here. And it looks like it's kind of a sister to these sharks here. So Squaliolus, Heteroscymnoides, and Euprotomicroides. So this is quite different. So it looks like the taillight shark is closer to these guys than it is to the pocket shark. And I'm just going to look up really quickly what these are. I'm going to just check sharkreferences.com. Or sorry, the Sharks of the World. As far as what Squaliolus is, because I'm actually not 100% sure off the top of my head what kind of shark that is. Okay, so it's a pygmy shark. Okay, so it says taillight sharks are actually closer to pygmy sharks. Are those all pygmy sharks? Those are all pygmy sharks. Okay. Interesting. Okay, so Squaliolus, Heteroscymnoides, and Euprotomicroides, these are all pygmy sharks. Some of the smallest sharks in the world. I feel like the record for small shark goes to a kind of lantern shark. I think it's literally called the pygmy lantern shark, which actually might literally be one of these species. Let me double check that. It actually literally might be the pygmy shark, Euprotomicroides bispinatus. Yeah, I think it's actually that. Okay, interesting. So this is actually really cool to see that the taillight shark is more closely related to pygmy sharks than it is to the pocket shark. But altogether, the pocket shark, pygmy sharks, and taillight shark make their own group. And that's a sister group to cookie cutter sharks and kitefin sharks. So it's pretty interesting evolution. And that's also an update from the last paper. Ooh, beautiful, beautiful. Oh, this is great, actually. All right, this might be the last thing for the night because this is actually really, really great view. And we've seen a study before, but this is always amazing to see. Just how bioluminescence works. So here we go. We have Delacius, so kitefin sharks, fully bioluminescent. Isistias, the cookie cutter sharks, they have like the collar. Mollusquama, which emits the fluid, and then Euprotomicroides. Here, Squaliolus, Euprotomicroides, and Heteroscymnoides, these are all pygmy sharks. So these guys are the pygmy sharks right here, which are fully bioluminescent. But here is Euprotomicroides, the taillight shark. And just want to zoom in so we can fully appreciate its name. So here we go. The shark does not have... It has like a dark belly, but it doesn't have bioluminescence except for the fluid that it emits here. So it emits bioluminescent fluid, hence the name taillight shark. Now what I'm kind of curious about is, you know how this species has white margins on its fins? I wonder if somehow they work with when the shark emits bioluminescent fluid. May not, but it's still pretty interesting to think about. And then here we go. So you can't see the shark in the dark, but you can see the fluid that it's emitting. Now I suspect this is probably mating. I suspect this is a mating thing, like an attraction for mating, or it could be predator escape. So, but could totally be wrong with that. So. But it's really cool to see all the bioluminescent sharks, lined up here, and we can see like a better view of them. Love that photo, by the way, or that drawing of the viper dogfish. You can see it unhinging its massive jaws. Love that. I'm gonna zoom out of that. Oh, there we go. This one's gonna end us for the night because this is actually gonna have more notes on the taillight shark. Okay, so taillight shark excretes bioluminescent fluid. Okay. Got that. Here we go. Researchers have formulated more speculative functional hypotheses regarding luminescence to some species. For instance, the luminescent liquid ejected by the pelvic pouch of the taillight shark probably works as a defensive smokescreen mechanism. Given the morphological similarity of the pectoral glands, and identical functions have been suggested for the pocket shark. Mollusc colma. There we go. Very cool. Secretory glands ejecting bioluminescent fluid in the environment, present in the taillight shark and pocket shark. The secretory epithelium for the pelvic pouch of the taillight shark displays a pseudostratified columnar epithelium. We talked about that in the last paper. Oh, this is interesting. The epithelium of the putatively bioluminescent fluid producing pectoral pockets of the pocket shark shows surprisingly different structure. So, even though pocket sharks and taillight sharks both emit bioluminescent fluid, they do it in a very different way. Interesting. The secretory luminescence observed in the taillight shark, which might have evolved from the invagination and modification of epidermal photophores, represents an example of the high selective pressure occurring in the darkness of the deep sea. Okay, so this is an interesting, if I'm reading this correctly, what may have happened in this shark's evolution is that it had bioluminescent photophores kind of like lantern sharks, and then eventually over time those photophores may have evolved inward and been reincorporated as fluid, if I'm reading that correctly, but that's kind of a huge speculation. But it is interesting to think about like what evolutionary pressures impacted the shark in such a way where it's evolved this kind of fluid. Squids famously do this as well, like a lot of deep sea squids, or actually I forget if it's like a copepod or a krill, it's some kind of like shrimp or copepod. They also emit bioluminescent fluid, so it's something that has evolved in nature a couple different times as a predator avoidant thing. So it's really cool. All right, well, it's almost 11. I just want to scan this to see if there's anything just brand new. Okay, the pouch on the taillight shark, located immediately in front of the cloaca in both the male and female specimens, shows indeed several morphological similarities to the pocket shark. Secretory tissues of the taillight shark pouch. Okay. This is a study. This is one we saw when we did the pocket shark episode, but let's see. I think it's just talking about the taillight shark in comparison. They've evolved these features differently. Okay. Okay, pocket shark pockets and the taillight shark pouch are used in similar smokescreen predation avoidance contexts, potentially blinding approaching predators. Okay, very cool. Okay, and I think that is a different kind of paper. So, but I do want to go back to this as kind of like a final view to end on. I really love this bioluminescent comparison column. So, all right. I feel like a similar thing happened. I feel like this always happens when we talk about deep sea species, where we think it's not going to be a lot of information because they're so rare, and then at the end of the day, it's actually quite a bit of information, and there's more than the shark offers than originally met the eye. So, but it's 11 o'clock over here, so I think we'll wrap it up for tonight. But thank you guys so much for watching. This was a really cool species to cover and a really cool stream as far as never heard of a taillight shark before, and yet it turned out to be one of the most unique sharks I've ever seen as far as just, there's no other shark that emits, I mean, pocket sharks emit bioluminescent fluid, but there's no other shark that does it quite in the way the taillight shark does. So, but thank you guys so much for watching. This was a really cool species to cover, and next week we'll tune in for a shark with a lot more footage, a lot more in-life footage, and I'm excited to see. We're going back to the shallows to meet the broad-nosed seven-gill shark, Notorhynchus sepidionus, so, which is a great suggestion. Thank you, Howard. But hope you guys have a great rest of your week, and tune in next week for the broad-nosed seven-gill shark. And also, thank you, Howard. Have a good night as well, and we'll see you next week. So, cheers, guys. Bye.